So I wanted to start going over some of the math concepts that students have asked my help with. And the best way I thought to do that was to try to make a few short videos about them. The first one I'm doing is temperature conversions because quite a few people asked me for that one. So by definition, just reviewing, temperature is a quantitative measure of how hot or cold something is. And as we discussed in class, all molecules are moving. They're always in motion. So temperature is linked to how much those atoms are moving. And we call this kinetic energy. So when you go and you Google the definition of temperature, you'll find out that it'll say something about how hot or cold something is, but it will also say that it's linked to the kinetic energy of atom scale particles. So if you have a glass of water and one is measured to be hotter than the other, this means that its water molecules have a higher average kinetic energy, so they're moving more than the cooler glass's molecules. So the greater the average kinetic energy of the particles, the higher the temperature. So just like we talked about, the more motion, the hotter the temperature is, the higher the temperature is. So we use a thermometer to measure temperature. A change in temperature causes a change in the volume of the liquids due to the molecular motion of the molecules. And this change in volume results in a change in the height of the liquid. And this is how we measure temperature using a thermometer. And the three common temperature scales that we are concerned with in this class include Fahrenheit, Celsius, and Kelvin. So temperature scales, when we compare them, Fahrenheit, we know that water freezes at 32 degrees Fahrenheit and water boils at 212 degrees Fahrenheit. Whereas at Celsius, water freezes at 0 degrees C, boils at 100 degrees C. For Kelvin, water freezes at 273.15 Kelvin and water boils at 373.15 Kelvin. Kelvin is the SI base unit. And we talked about in class that 0 Kelvin is the temperature where all particles are at their lowest possible energy state. They're basically not moving. They're still moving slightly because we say that molecules are always in motion, but they're essentially not moving detectably at that temperature anymore. The temperature conversions. These are the two equations that we've been using in class to convert between temperatures. So we have one that allows us to go from Fahrenheit to Celsius and the other one from Kelvin to Celsius. So based on what I saw on your Chapter 2, Part 2 test, I believe the problems with converting between temperatures are the result of two issues. One is rearranging the formula correctly, and the second is paying attention to sig figs. So I want to work on rearranging the formulas for a moment. So I want to start with the easier one first. So we're going to start with this one and rearrange it to solve for degrees C. So I'm going to use an app here for the first time. So hopefully I can get this to work okay. All right. So we had Kelvin equals 273.15 plus the degrees C. So if we're going to rearrange this and solve for degrees C, like we did in class, we would circle it, and we have to subtract 273.15 from both sides of the equation. When we do this on the left side, we get K minus 273.15. And then on the right side, this cancels with this, and you're left with degrees C. So rearranging it so it's a little bit more user-friendly, degrees C equals K minus 273.15. I believe that equation is pretty straightforward. It's the second equation that I think causes students more issues. So let's take a look at this one. Degrees Fahrenheit equals 1.8 times degrees Celsius plus 32. So with this one, we first start out, we have to recognize that we're trying to solve for the degree C. And so we're going to have to isolate that on one side. The first thing is to get rid of this plus 32. So we're going to subtract 32 from both sides of the equation. When we do that, we're left with degrees Fahrenheit minus 32 equals 1.8 degrees C. And these two things cancel. So that's what we've got left. This is where I find most students make their mistake. So at this point, you have to divide both sides by 1.8, which means that you have to divide the entire left side by 1.8. So you end up with degrees C equals degrees F minus 32 divided by 1.8. So many times I see this equation being rearranged where students don't take degrees F minus 32, that entire quantity, do the subtraction, and then divide it by 1.8. So when you do that, you'll end up with the wrong answer if this is not how you do it. So that's how you rearrange that formula. So after having rearranged the formulas, you really need to pay attention to your sig figs. So however many sig figs your original temperature has, you need that same number in the temperature in whatever new unit you are. The conversion factors equations themselves have unlimited sig figs by definition, so you really only need to concern yourself with the sig figs of the original number. So if you're converting 25.7 from degrees Fahrenheit to degrees Celsius, your final answer in degrees Celsius must have 3 sig figs. So as far as those are concerned, practice is the key to making this easier and having this work better for you. So you need to rearrange that formula repeatedly until it becomes easy and you don't make any mistakes. I recommend doing it on multiple different days until you're confident that you can rearrange both of them successfully. Do a couple of conversions. You've already done quite a few in your Chapter 2 packet as well as in your textbook, but as a reminder, here are places where we have some temperature conversions available to us. Yellow page 6, textbook section 2.7 has examples, and these are some problems at the end of the chapter in Chapter 2 that had some number of different temperature conversions. And if there's any of these that we didn't do in class and you just want the answer just to check yourself, let me know. I'm happy to post these out or share these at any time. I think for the most part, once you have the right equation, most of you are pretty comfortable with plugging the numbers in. So I hope that this answers the questions that you have on temperature conversions.